Today I'm going to talk to you about probability, what it is and how we can determine it. So probability, the definition, is going to be the likelihood of something happening. All right, when we talk about the likelihood of something happening, we measure it on a scale. Of 1 to 100, or I'm sorry, of 0 to 1, I apologize. I'm thinking percents, which you can express a probability as a percent. We'll talk about that in a minute. From 0 to 1, it can be expressed as a fraction. I'm going to put a star next to that one because fraction is the most common way to express probability, as a fraction, a decimal, or a percent. The way that we notate this, we say P, capital P is for probability, and then parentheses, we put the event that we want to happen. So here you can see my number line. If it is not ever going to happen, right? Pigs are going to fly outside our window, right? That is a 0 probability, right? So we can write it just as 0. We can write, if we wanted to write a decimal, we say 0.0. If we wanted to write it as a percent, 0%. If it is absolutely certain, okay, in South Texas, in the summer, it is hot, that is an absolute certainty, then that is a probability of 1. So we can write it as 1, 1.0, or 100%. If it is as likely as not, so that's a 50-50 chance, then that is a probability of 1 out of 2. It's going to rain today. We have a 50% chance of that happening. It either is or it isn't. And then we have unlikely. Like, it could happen, but probably not. But maybe, so maybe 1/4 is fairly unlikely. Doesn't mean it's absolutely not going to happen, but it's fairly unlikely. Likely means it's probably going to happen, but there's a slight chance that it won't. So we could say 3/4, 0.75%. Okay, so those are just kind of how we scale things to see what it would look like. Okay, here are some examples of probability. If we roll a 6-sided number cube, also called a die, which is singular for dice, right? So the numbers, whenever you see a 6-sided number cube, we're talking 1, 2, 3, 4, 5, and 6, and it lands on a number 1 or greater. Well, that is certain because you can see that the numbers on a number cube are in fact 1 or greater. So this is a certain. Like, it's gonna happen. There is a probability of 1, right? Because all of these numbers are greater than 1. B/C for because all numbers are greater than 1. But if we have a bag that contains 5 red and 5 blue, and usually when I see something like that, I usually just make a little note out here to the side so I can see what I've got. And you reach into the bag and you pull out a purple marble. Well, none of these are purple, so this is going to be a 0 possibility. This is going to be impossible. This is impossible because there are no purple marbles in the bag. Okay? There might be purple marbles somewhere, but not in this particular bag. If we have a spinner that is divided into 5 equal sections labeled 1 through 5, you spin it and it lands on an even number. So if these are my numbers, 1, 2, 3, 4, and 5, and I want an even number, we could even write P parentheses even. Well, I have 2 of those possibilities out of 5 total. So if we go to our number line, 2/5 is kind of in between here. So we could say it's not as likely as not, but it's kind of unlikely, right? And the reason is there are more odd numbers than even numbers. Okay? So those are some examples of probability. So on our next page, let's talk about actually finding probability. So P parentheses event, right? That's how we show probability. And it's usually written as a fraction, as you can see. And this is the number of times a specific event occurs, right? That is what you want, right? In the last one, it would be our even number, out of the total possible outcomes. Okay, so what we want over our total. So these are examples of quantitative probabilities, right? Quantity meaning number. All right, so here we have a spinner. What is the probability of landing on an even number? So we would write P parentheses even. That is the probability we are looking for, and we can count. I've got 1, 2, 3, 4 even numbers. That's my numerator. That's the event that I want. Out of the total possible, I have 8 possible outcomes. Now, this is a fraction, so you do need to make sure that you simplify. So our probability is 1/2. If you go back to our number line, it is equally likely as not likely. So what does this mean? This means that every 1 out of 2 spins will be even. Okay. What is the probability of picking a heart from a standard deck of cards, which has 13 cards in each of the 4 suits, diamonds, clubs, hearts, and spades? So if you don't know about decks of cards, there are 52 total cards. That does not include jokers in a deck of cards, where you have 13 diamonds, 13 clubs, 13 hearts, and 13 spades. So if we are talking about picking a heart, we can say the probability, you can write heart, I'm just going to draw a heart. Probability of a heart, well, there are 13 hearts out of 52 total cards. Now, I will tell you that that does simplify by 13 to 1/4. So this is a fairly unlikely, it's not impossible, but fairly unlikely that you would just randomly draw a heart. Because this means that every 1 in 4 cards drawn will be a heart. Okay. What is the probability of rolling a number greater than 4 on a standard number cube? So remember, a standard number cube, 1, 2, 3, 4, 5, and 6. So greater than 4 is just going to be 5 and 6. So the probability of a number greater than 4, that's what we're looking for. We have 2 of those possible outcomes out of 1, 2, 3, 4, 5, 6 possible total outcomes. 2 are what we want out of the total. This simplifies to 1/3. So that means that every 1 in 3 rolls will be a 5 or a 6. Okay, so that is how we find probability. Now, on all things math, there are opposites. So probability, when we talk about the opposites in probability, we are talking about something called the complement. yes, I spelled that right. So a complement is the set of outcomes that are not, capital not, included in the event. So let's talk about what that means. Okay, so if I said a minute ago, what is the probability of getting a heart? The complement or the opposite is getting any suit that is not a heart. Okay, so this is just what you don't want, essentially. All right, our numerator is what we want, so our complement is what we don't want. So we can say all outcomes over a total, this just really is one whole, minus what we want out of our total will give us our complement out of our total, or what we don't want. Okay. Our complement, you can also say down here, our event that we want, and our complement, which is what we don't want, will always equal one whole. Or if you're going to write it as a percent, which we don't do a lot of, or 100%. Okay, so let's do some examples of that. What is the probability of not rolling a 2 on a standard number cube? So here are my numbers on my number cube. 1, 2, 3, 4, 5, and 6. So if 2 is what I want, not a 2, this is our complement, right? So we can do a couple of things. We have 6 total outcomes, and we can minus what we want. Want is 1 out of 6, and we get 5 out of 6. This is my complement, because this is representing a 2, and this is not a 2. Now, most of you could probably look at that and go, well, if we want a 2, then we have 1, 2, 3, 4, 5 left. That is our complement. But I want you to see the math of it. Another way you could write it is, you know that 1/6 is what you want. This is your 2. This is your not a 2. Equals 1/6 plus 5/6 is 6/6, which is your one whole. Okay? So remember, that is this 5/6 is that complement. That is what you don't want. If there are 13 diamonds in a deck, standard is 52. You pick one at random. What is the probability of not a diamond? So again, you could say a whole, 52 over 52, minus what we want, 13 over 52. This is your diamonds. And when I subtract those, I get 39 over 52, which does simplify by 13 to 3/4. So your complement is 3/4. This is your not a diamond, right? Because there are 3 suits out of 4 total suits that are not diamonds. The other way you could do this, you could say what you wanted, which was diamonds, plus, I know 39 and 52, these are not diamonds. This equals that 52 over 52, which is one whole. Now, you do need to make sure you go back and simplify that. A spinner has 5 equal sections, A, B, C, D, and E. What is the probability of not a D? Well, if D, this is 1 out of 5, we can see that 4 out of 5 is the complement, right? So we could say probably, I'm not going to write it like this. I'm just going to write it shorthand. Probability of a D is 1 out of 5. So the probability of not a D is 4 out of 5. And you can see when you add those together, you get one whole. So do a little bit of practice for me, and we'll discuss later. Have a great day.